Okay, we come now to the last presentation, to the last tutorial by Guido Wirtz from University of Bamberg. Very nice town, as you see with the first pictures here. That's Little Italy, Little Venice of Bamberg. Very nice, and yeah, and I guess we will not only talk about Bamberg, but also about platform as a service and portability.
Thank you. So, good morning, everybody. Because everyone tried to make some advertisements for his university or her university to hire people, I have to do that also. These are pictures of Bamberg. This is the old part. This is our institute where all the computer scientists are in and have to work there. And we have been founded in 2001. I was then in 2002 the third or fourth professor there. We are now 70 professors, and we have 3 departments: applied computer science, information systems, and I'm in the middle, computer science, classical computer science, and we do almost everything that's not so close to home. So, and my group works on service-oriented architectures, service ecosystems, clouds, especially platform as a service, as you will see in a minute. And also what is interesting for me is the transition from business process from these high levels down to the implementations in distributed systems. And for a long time I've been involved in visual design and programming languages, so I also had an interest in things like BPMN and Beeple as more or less visual process definition or description languages. So we're also hiring PhD students and postdocs, just to have said it, but I think we have an offer now over the 3 or 4 days for about 50 positions, and maybe there are 2 or 3 non-employed potential PhD students left, so we have to fight about among them. So the real title of my talk is Platform as a Service, Models and Portability. This is a little bit of a tutorial, but as I wasn't sure how much real students and PhD students are still here, more or less we have, I think, more professors now. I also decided to do a little bit and talk about the work we've done in the last years on platform as a service and portability. And the main work of all these things is by Stefan Poll. Unfortunately, he can't be here today because on Wednesday he had to give a talk on the IEEE Cloud Computing Conference, and that is in Hawaii. So, unfortunately, it couldn't be a treat here, so we had to be in Hawaii. So we had a similar disclaimer, I think, 3 days ago by Norman Twitter. If you really want to details, you may ask him, but I try my best. Because that's maybe the first lesson for all the PhD students here. If it's going into the details of your PhD and especially the implementation parts, not the overall view and the theoretical aspects, if you don't know more about it than your supervisor, you're in bad luck. Because he will, every time he will come with some crazy ideas what you should have to do, and if you know more about it, you can explain to him why that doesn't make sense at all. So, talking about clouds, I don't think we have to go into the definition and these 5 essential characteristics from the National Standards Institute of the US. So this, we all know about it, we heard about it in the last 3 days, and we have these different kinds of clouds where private and public are the most important, and we have a bunch of service models. We will talk a little bit more about platforms as a service in a minute, but we all know this hierarchy from serving software solutions directly to the customer, and the customer simply use them. On the other end, you don't have to run your own data center or your computer center because someone does it in the net for you. So you get the infrastructure, the iron, maybe even the operating system. And then we have all these things in between, and that's a real big spectrum, as we will see, because, for example, what about containers? Are they, maybe 5 years ago, someone would have said container as a platform as a service issue. If you think about containers nowadays, maybe it's more closer to infrastructure because it has been got so common. And we not only have these 3, if you look on the net, you have everything as a service nowadays, which means communication. If you, for example, look for CAAS, you have cars, containers, whatever, communication as a service, where communication as a service from the carriers makes the most sense of these. We have backup as a service, we have business process as a service, and you can have an easy grammar, which means give me an S, and as everything is a service, so you have S as a service, or X as a service, everything is a service. But if you look closely at these things, a lot of these things are not that new. You have some users who don't have their own computer resources anymore, or only sync lines or things like that. Then they may use some software from a software as a service vendor who does all the computing for them. And if you look behind the scenes, maybe the SaaS vendor has its own path provider and may have in different geographical regions in the world have some infrastructure provider. So in the end, you have the classical layer computer science model with all these things, abstraction towards the end user. And when you go step by step closer to the detailed environment, you run into the same trouble you ran into maybe 20 years ago, because you have to manage all these things at one level. There is no magic in it that does it for itself. So with all this behind, so one cloud will not fit it all. And so we have a lot of vendors that offer different things, and we also have a lot of big players who offer, like Google, also offers on different levels. And it's not only the big players, it's a bunch of players, and these are by sure not all, but there are a lot of them. And that is one of the problems, at least on this side. For a SaaS, for example, you may know what you want to do, what you need for your business, what you need for your company, whatever. And then you may have a small set of vendors that deliver software which is especially dedicated to this kind of job. And then, sure, you have the problem of choice, but it's not so hard. The same here. You may have a lot of infrastructure providers, but more or less it's the same hardware, it's the same software. You may have Windows, you may have Linux containers, things like that. You may have different container technologies, you have different machine technologies, but it's not so different. The real problem lies here, as you can see, because when you look at this nice picture that you all know, I think from the user's point of view, when we look at the platform as a service, we talk about something where you only, in hypothesis, have to care about your applications and data. And so runtime, middleware, and operating systems are provided by you, so you have much less to do than, for example, an infrastructure as a service, but you're still able to implement your own applications using a DevOps cycle or something like that, in contrast to software as a service, where you get a complex software you may configure a little bit, but not so much. So our research and also the tutorial scope is on paths, and I will give you some reasons because why we do that. If you look at the definition from NIST again, we all know what path is, but I think the real problem is here in the blue part. It's sure you can deploy your cloud infrastructure, consumer created, that means you can do that all, but you have to use programming languages, libraries, services, and tools supported by the provider, which may be anything. And in this anything, there's a lot of more of heterogeneity and diversity compared, for example, to hardware. If you look at hardware offer from HP or from IBM, they claim they are completely different and everybody is better than all others. So when you put them all together, they are all equal. But here you have a real problem. And from a point of view, not from a business, but from computer scientists, you also have to think about when you go for a PhD or go for your research projects and you want to do research, what do you choose? Maybe what the reason we choose paths 3 or 4 years ago. Using apps over the net is nothing fancy anymore. Providing iron is easy nowadays. There's a lot of work to do, sure, but computing centers do that for decades, more or less. Successful hardware and basic OS are standard. Virtual machines and containers make everything even much more easy. So, but in the middle, providing complex working environments is not that easy. Maybe for the provider, but on the user side now, you have to choose which one of all these you have to use, which kind of databases, which runtimes, which script languages, and so on. So even from the business side, also things like cloud, this is a Gartner study from February this year, cloud business process services are expected, as well as cloud advertising and SaaS to be the main markets, but even cloud application infrastructure is some market. And there's a reason for that, because first of all these other offers have to be implemented by someone. And you want to have new implementations, you want to have better implementations, you want to have updates and all these things. And in essence, these things all depend on some environment where you program and then on some infrastructure where you run your system. So the benefits of a hosted environment, you have less hassle with distributed system issues to some extent. To be honest, you don't have to do so much configuration, but the downside is you can't do so much configuration and instantly can become productive if you know your environment. Especially if you go from an on-premise development cycle to the cloud and you get exactly the same environment that you have on-premise, it's much easier for you to do things because a lot of things like updates, security, patches and things like that are done for you. And you pay for what you need, it's transparent scales, as we all know, and your IP, that's the real business case, grows dynamic business. So you can save money and focus on development and running applications. If you look a little bit closer on this part, there are different notions of paths, and it's not really clear what is a path at all if you go into the details. The big picture you have seen is easy, but if you go into the details you have a problem, because the question is what is in the box. Which kind of languages, which versions, which runtime versions are you allowed to use parallelism for yourself, multi-threading, things like that, which kind of middleware stack is supported, which kind of databases are supported in which manner and so on, and we also have a lack of standards here, because this is so diverse, standards make more or less no sense, in my opinion. So that's a problem, because developers have different needs. Software stacks contain complex dependencies. If you want to have this, you have to additionally install that and so on. And on the other side, if you look at the vendor pages, they are, to be polite, bragging about the offerings. Normally they are lying. Everything is working, and if you try it, you run into trouble, so you have to use what you get. So one question is how to choose the right PaaS platform for you as a user, as a developer. And the other question is what happens if there are some reasons you need to have a new platform. To give some examples, these are more than 70 PaaS vendors that I think most of them are still up, because you have to look every day to keep it up, keep it present, how to choose one. So the choosing is not so easy at all. The second is sometimes you may want to change simply based on cost. For example, here you see some simple cost. I think it's 2 or 3 years ago. If you have 2 instances of a machine per month for these small things, or you have 1 virtual machine per month with these ones, because they're virtual machine based, you have different costs. And so you may change from something like that to something like this. This one is a good example to change, because you will see the other reason you sometimes not only want to change, you have to change. If you look, for example, here, it's from February last year. Unfortunately, we have to shut down the cloud control path. This is this one. And it was one of the cloud platforms we used for our experiments. And in between, even in the experiments, it was shut down. So we ended up not with 4, with an interface afterwards. You will see that interfaces to 4 cloud platforms, but only to 3, because one is dead now. So for a PhD, that's not a problem at all, because we have shown that it works, and we have still 3 left. For a company that is really based its business on this provider, you have a problem. And then the next problem will be sometimes things not only are shut down, they are consolidated, bought by someone else, maybe from a different country you don't want to have your cloud applications on, like the US or something like that, or China. So these are reasons that you have to change. Maybe even for regulations like you you're not allowed to have your data outside the European Union or outside Germany. So the main issues with all these PaaS offers are, first of all, how to choose the right offer. And what we should provide with that is a comprehensive, also up-to-date and reliable criteria to do that. And in essence, it ends up with describing all these offers attribute-based in a model and as profiles, and then you do an attribute-based selection. The second is how to avoid vendor login, which means when you choose a platform, you should at least try to find some other platforms which are also reliable, maybe more costly, but also reliable, that offer the same or at least similar environment. Then you can be more or less sure that if something goes wrong, because a cheap offer will be dead in a year, you can at least, without too much hassle, migrate to a maybe more costly offer, but then it would be reliable. So you have to provide a suitable operational decision model as basis for that data. And the other thing is how to additionally facilitate migration. If you think about more fast migrations, like in the DevOps cycle, you can't do everything automatically for 50 different vendors. It doesn't work. So what we did here, and this is the third part of my talk, we concentrate on the most time-consuming issues, which is mostly management of the thing, deployment and things like that. And on the other hand, these are so easy that at least for a lot of vendors, you can abstract from details via a common interface and adapters without too much cost. So besides having this model, we provide a common API and its implementation, because an API without an implementation makes not so much sense in practice, to at least deploy things for different vendors, at least 3 or 4 vendors in the same fashion. So to get to the model, we take a closer look at PaaS. And what we did there was we noticed all these different notions. We did literature review. We analyzed 76 PaaS vendors 2 or 3 years ago, and we're still also, the new ones coming in, we're still doing and define a PaaS model for that. Extract from all this based on the PaaS model the comparable components, capabilities as attributes, which end up in PaaS profiles for all these vendors. And then if you have to choose between the heterogeneity between different vendors, and that's a problem, you can do something we call application portability matchmaking. And in the end, we also have, I will show you an example of a feasibility use case for ported Blinkist onto 3 or 4 platforms. So this sounds almost trivial if PaaS is in between software as a service and infrastructure as a service. And you look at the PaaS offers, some of them are more close to the infrastructure level, and some are more close to the software-centric level. On the upper level here, these are things where you have maybe a little bit more on chances to configure things and so on. You are more productive, and your more management is done for you. And on the other side here, you are almost free to do what you want, because it's only a composition of low-level services. And we concentrate on the middle here, because these both are taken into account the classic app environment, where you have things like Heroku, Cloud Foundry, OpenShift, or the Google App Engine, where you can have entire stacks of software developed, because this captures the problems we have best. So that's our model. It's also in 3 levels. I will go into the levels in a minute, more detail. That's close to the infrastructure, that's the management, deployment, and all this thing. And this is the thing that's really typical for PaaS, which means different runtime stacks, like APIs, middleware, whether you have a .NET framework, you have an Apache stack, things like that. You have different languages like Java versions and so on. And on the other hand, you have native services, which are provided by the, we call it native service because it's provided inside the cloud, in the PaaS cloud offer. And you have, maybe if it's allowed, also add-on services, which means you're allowed to get things from outside, and you're allowed to use other services from outside providers in your cloud. And in the last years, something that came into the picture also, I think Heroku calls it build packs, others call it have other names for it. This means if your platform doesn't provide everything, but there is for the thing you really need, a simple build pack that you can install with one command, and it's allowed for you by the cloud provider, it's mostly as good, almost as good as it would a native service, because you can make it to a native service to deployment. And so you have also to take that into account. That's really important for matching things, because if you look for a platform and something is missing, the first idea would be to say you can't use it. But if there's a build pack for it and it's installed with one deployment job automatically, you have to match it also. So a real hard matching of all attributes not always makes sense. So this is the infrastructure layer. We notice from all vendors whether there's vertical or horizontal scaling. There's deployment models, whether it's public or private hosting. Then geographical regions are also important for where is your data. Maybe also latency may play a role, but also legal reasons like acts like the health regulations, things like that. If you work in the health department, where are you? And also things like standardized service auditing and things like that, because some of the applications you may run require systems where it's really important that the provider has some certificates and things like that. So you can also put that in. So on the platform layer, you have all the things I've already told you. It's the boundary to the infrastructure, third-party providers like a single sign-on or something like that. The native services inside the cloud, and also the additional APIs that are provided by the cloud offer itself. And on the management, we at the moment ignored authentication, billing, and monitoring. Billing is a little bit in the system with a very simple model, but what's important here is deployment cycles, service provisioning, scaling, and all these things. And all these are accessible via a web user interface, also command line interface, and it's also interesting if there's a REST API to do automation with these things. So, to select the right path, then this model provides us with the background to build these profiles. We extracted all the attribute sets from the vendor data. That's sometimes really hard. We categorize them into path profiles, and at the moment we have a searchable dashboard. It's online. I will give you the link in a minute, with more than 70 current offers. And the nice thing is, even especially small vendors, if we contact them and try to them to explain what we are doing, they're even willing to look at their profiles and to give us corrections if we read something wrong in their descriptions, or if they change something, they even notify us and update the profile. And even sometimes if someone sees there's something missing, what already almost everybody has, a month later we have an email, we also provide now this kind of language or something when the new language is coming up. And so that also helps to some extent, although it's very simple.
Even Google and Amazon?
No, small ones.
Small, okay.
So Google and Amazon I wouldn't call small. Not from an earthly point of view. Maybe from Andromeda or something like that. Only small ones, middle-sized also. Especially German locals or... Okay. And the other thing then is portability program, but we call it, if you have an application and you're a developer for applications, you normally know what you want to do, what is the environment, what you want to use. And then you also provide some kind of profile, or in the back of your head you have the profile, which stack you need, which runtime language you work with, is it compatible with this kind of database, do you need a MongoDB or something like that. And you describe your needs as a path profile, and then matching is done at the moment, very simple attribute matching, strong matching, to find all the matching providers. That's no magic at all, it's very simple. And then you can decide among the results you send to the office, maybe, for example, you choose someone who's close by or had some interaction before and to see if the service is good. So that's the ecosystem, we call it the ecosystem of components and capabilities. You don't have to read that. Describes runtimes, frameworks, middleware service, extended build, hosting, scaling, for example, vertical, horizontal, or automatic, and the infrastructures there that are allowed. Then you have native service, name, description type, version, add-ons, name, URL, description type, and so on. And the infrastructure here means not infrastructure as a service, because that's not a good name at all. I noticed when I made the slides, continent, country, region, provider, and maybe even some business things like whether it's standardized or something like that. Then status, pricing, and compliance to things like a health hack or other things when you go to finance. Here's one of these profiles. It's a JSON profile. And you see all the things in meta level, the name of it, the business part, pricing, fixed monthly, the technical components, scaling, hosting, infrastructure, North America, US, Virginia, and the web services, runtimes Java 1.6, 1.7, and so on. You have some frameworks like Ruby on Rails, you have Tomcat with Java, and so on. In MongoDB, that would be a typical example, but you're not allowed, although we can all read these things, you will not have to read and write this description language because there's a web interface where you can choose among all these parameters, and then this profile for your needs is generated and then matched against the others. But you also can look at the details of these profiles. So we have 4 applications for these profiles because it's machine and human readable, and they serve as some kind of catalog. One is if you want to go to the cloud, you know what you have, and you find also providers that deliver a similar environment. Then, if you want to deploy on a single pass, you can check whether there's anything you have to install additionally or what is inside the cloud. If you migrate between clouds, you can see which one may be the lowest level of hassle. There will be some hassle anyway when you migrate from A to B. And if you have a real complicated application that needs a lot of things that almost no provider provides, you can even identify the supportable building blocks that you can port, and then you have to think about the other parts.
Here, what is the inherent difference between migration from on-premise to PaaS and pre-PaaS? It's
simply another use case. From the technical aspect, it's nothing. Maybe it is if you're in a PaaS and you have a description of a PaaS, you know what you need. If you have an on-premise thing, you may be not so clear about what is there in the background on maybe 20-year-old technology you have to substitute. And so that's to come up with a new version. You may notice here that in the end you be more here than there.
It's much more onboarding.
Pardon?
It's much more onboarding. Yes, it's a different question.
Yeah. So here because if you're in the past, you know what you have and you know what you want. Yeah. And you don't, maybe not here. I think normally it will be, you end up with something in between here when you do it for the first time. So that's it. Profile matching is the essential basis for all these things. That doesn't mean it does all the work for you. It only gives you information how much work you have to do. To make that clear, that's not magic. And so that's the idea. You have a web application with user-defined filter and the application profiles. You have also passwords and the matchmaking, and you end up with, if you're lucky, with some profiles. And this part is visual selection to satisfy the user, and this one allows you for automatic discovery also. So you don't have to use these JSON files. This is a snippet of the site, but I think I can also, if my connection is not dead, you can see this one. That's the Pathfinder.org site where we have all the authors. Then you have Find Your Path, you have Nucleus that we'll talk in a minute. You can compare some things with a one-on-one comparison. It's much like some other tools for some things you can buy on Amazon or something like that. There's a market statistic, and there's Parsia that we'll talk to in a minute, and also all the applications. And you see that's a snippet. And these are the vendors. Production status, alphabet, or in production, you should choose something with production normally if you have the money. And these are all the runtimes. This is where the scaling horizontal, vertical, and the cycle means automatic. And then hosting private or public. And these are the regions where you are. And if you want to see the details, you click here and you see the details also. And all this I showed here out of the presentation. You also, for all these things, there is a GitHub repository by Stefan. All these things are also as the profiles. All these things are nucleus and so on. Also there's the source code. So everything is open to use. Okay, so this 70 vendors, and I think that's the most comprehensive and up-to-date list there is on past profiles at the moment. If somebody knows someone who has a better list, I will contact him and we will try the efforts. Because I think there's a service we can give to the practice, and a lot of people use that. It's more than 2,000 users per month. There are a lot of research users, but also some real business interest users that try to find the right path. So what they're looking for, the first everybody looks for is that's a typical thing, free hosting. So production readiness, private path, PHP and Java. And in the end I will tell you a little bit about question when it doesn't match. The paper Stefan at the moment, or on Wednesday presented at the International Cloud Conference in Hawaii, was about more advanced matching, because we analyzed all these searches and we found that a lot of searches fail because someone wants to have 10, 12 different factors and nobody offers. And the other thing is people want to find things that are not built in but can be built in with a build pack or something like that. And I have a link to this. I have a link to this paper. And the papers are also provided on a website. So I think that's a real nice thing. The feasibility study, it was Blinkist. It's a little bit obscure for me as someone who reads a lot, a little bit of an obscure German company. They provide you with, at the moment, I think more than 1,000 books. And the key insights of all these books are put together into a 5-minute or 10-minute read, depending on the complexity. So if you don't want to read any non-fiction, but you want everything, you use them. And they have about 350,000 registered users. At least they can still read. They have to read. But maybe with the phone you can let it, you can listen to it, and it's read to you. So that was the thing, because it has some nice needs for the path. So we started with this 70 vendors, and what you see is they want to have a public path, production ready, with scale out, horizontal scaling. They use Ruby in the back end, Rails, and a Puma web server. They have a MongoDB, and on the other side, for caching, they use Redis, and for content delivery, as a content delivery network, they use CloudFront. So these are realistic needs for such a cloud application, because it's a real application that works. And that was the basic idea of everything. Then we end up with 22 of these 70 vendors, and you see these things work. It's very easy, but the most important thing here is it's possible to model real existing and working path environments and their needs with the system, and then come up with results. Okay, the current drawbacks, we only look at the business and the ecosystem perspective. There are a lot of low-level things. For example, if some things are allowed or not, it's sometimes not clear. You should have something like, maybe for fine-grained implementation details, you should have some tests like unit tests or things like that, to put them on the cloud and see whether it works or not. We did not dig into that so far. And at the moment, matching is relaxed to partial matching for the reasons I already told you, to take easy to install add-ons and build packs into account. If something is not native, it may be as an external service allowed, and we are always open for suggestions for enhancing the entire model as well as the profiles, because this entire effort can only get better. So, okay, so that's the recent paper from the cloud. The next then is an additional part of the work, how to facilitate portability efforts if you have found the path works. So, as I said 20 minutes ago, not everything can be done automatically. So the first thing you do is, if not everything can be done, you look for two things. One is analyze the details and you find what is possible and what really helps. If something reduces your efforts by 2%, forget it. But if it's a real big issue and it's doable, then you have to try to do it. So that was the first one. And then we concentrate on these feasible aspects that are applicable to a wide variety of vendor platforms, and also supports what we have in background here with the PaaS system is some agile techniques where we say someone wants to update his and expand his application, that you want to do it in a real fast DevOps cycle, which means you want to have it automatic. And so we provide an API for typical development lifecycle also. So that now is again a part which is dedicated to tutorial, no measurement without matrix. So we base our things on the ISO IEC square quality model for code-based matrix. This is not something we found out recently. We worked on that when we talked about edit distance-based patterns in process languages. We used this kind of thing also, this matrix, when we analyzed process engines and how to port from one process engine to the other. But we adapted all these things: average deployment time, deployment reliability, which means how often you have to repeat your deployment steps. And that's, for some of these clouds, it's really bad results. Then what on code change? And code change means not so much code change in the sense of Java programs and so on. Normally lines of code in configuration files, lines of code change in application codes, number of parameters to set, number of paths to set, and things like that. And then the build steps, and also the steps to deployment and the number of input parameters you have to set each time for yourself. And if you look at these things, and you want to measure things, that the PaaS is also on GitHub. It's a lightweight Docker-based automation tool for repeating all these workflows, and we also did that normally 100 times. The problem with all these measurements is with containers as well as with cloud platforms, you always have to start from a fresh one. Because, for example, you would see deployment may last 20 minutes, a redeployment may last 7 minutes, and things like that. Or even if you have deployed something and you try it again, it doesn't work at all because something goes wrong. So you have always have to have fresh environments, and so containers and things like Docker are really helpful. So we did 100 runs each for all these at varying times, a little bit to simulate different loads. We also did it to some extent in parallel. I know that from a point of measurement performance, that's a little bit weak, but it was at least to show that if we do things in parallel on the same host, on the same cloud provider, there are some differences to doing it freshly only once at a time. And we also manually analyze the development scripts for all these parameters, like setting parameters, deployment steps, and so on. So that was done also with the Blinkist for these 7 providers. This one is now, that's cloud control, so it is out of the game. And what we came up was the average deployment times. These 2 are virtual machine based and these are container based. These are minutes. And this is for the first deployment. I skipped the graphic for the second or redeployment. It's more or less for all of the systems 7 minutes plus minus 1 minute. So here is not much different, but here it's really different.
What do you think? Why is it changing a lot?
Fun?
Why is it changing a lot? What do you think?
The redeployment, it means that normally these things have been set up once, and then when you redeploy, they are already running. That's sure. So what we all tell people is, if you want to do some tests, do something container-based, and if you want to go real, you may think about VM testing. That's true. That's not a surprise or something. That's the reason you go. But then, if you look at all these things in the different colors, yellow means steps and parameters. I can give you, because I also had to write that on. There's the number of deployment steps, the number of deployment step parameters, the number of config and code changes, and the number of build steps, and all this in a metric compatible mixture, which we used before for other reasons. And this is the yellow part, and you see it, at least with almost all machines, it's a real big part of it. There are some code changes, and
code changes is the number.
Oh, the number here. This is the number of. We took all these steps I just told you and made a matrix out of it, but not a 1-0 matrix, but some weighted steps. We weighted the different things because setting parameters may be more hard than simply executing a push or something like that. And then we came up with an abstract number of steps you have to do, which means deployment steps, path settings, parameter settings, all these things, to get a crisp of how hard it is for a human to go from one path platform to the other, because you have to change all these things.
The code changes means changes in the application.
Yeah. And
please talk to Terry better.
yeah. And the point here is a lot of these things, and that's the nice thing, is really these almost simple things like we all do when we start something that was maybe 30 or 40 years ago. It was put in a make file, now it's in a start script or whatever. And if you look at the details you can find here, if you look at these things...
excuse me, can you go back? It's not clear to me how you can change the code and you cannot perform any building. It's not. People tell me Bluemix, but it's not any building. You change the code and we know how it works.
The change of code normally means... no, this is change of your own code. You get the Bluemix, and that's the application code. To some extent, that's also, if it's written well, you will not change the application code itself, but it maybe have an additional config file, and you change paths and things like that. We don't recompile the application from Blinkist and then change the code to get it running. But we had a close interaction with them. It wasn't not only took it, but we also talked a lot to them. But it's more or less, some people still put in passes and programs and things like that. We always try to shoot students to try that up, but there are always students that do that, and also developers that do that. Okay, and so you see the red one, simply management is for almost all parts very big. And I've already told you about the things like authentication on the system, create application space, customize and config, set of variables, and so on. And the real efforts, how it's counted with these numbers, can be found here. It's 2 pages of discussion how to do the matrix, and you can find it there. The nice thing about that, if you look, for example, one from Heroku, this one is from OpenShift, and this was from the now dead control cloud control. We organized it in a way that you see it. It's more or less all the same. And so what we do is we analyzed all these, at least for these 4, we analyzed Cloud Foundry, Heroku, Cloud Control, and OpenShift version 2. We analyzed all these things, and we came up with a lot of different operations we have to do in most of them. And instead of showing it this way, normally you can find it in a tech report described in detail on about 80 to 100 pages. It was also work of one of our master students. And the abstractions, unified interface lifecycle, I think that's very simple. We all see that create an application space, provision your application service like databases, configure your environment, deploy, monitor, scale, power down, recover, and also deploy. So all these different kinds of things are in this model. So that's very simple because the final automaton with something that what we did was implementing Nucleus that supports at the moment currently 3 vendors because the 4th is dead. It was Cloud Control. And with these 3, you have a lot of others which are based on these, and you can also provide help for the ecosystem. So this is the architecture. It's more or less the same we have seen over the last days. For other things, you have the API for the Nucleus yourself. It's Swagger-generated clients. You can have also command line interface. You have your repository for vendors, providers, and endpoints with a public API. You have authentication, and then you have your adaptive fundamentals and the adapters for the different things. And you can use this unified API for at least do the management for these 3 platforms. And it's also on GitHub and running. So unified management interface, language-independent API. It's extensible and versionable. It also has to be extendable because it's only 3 at the moment. And you can also forward to the native API if something doesn't work. So you can find it also on Stefan's GitHub page. So I have 10 minutes. A little bit about related work. Not too much, because we have heard about a lot of related work over the last days. I don't talk about portability for clouds in general, and I also skipped the part for interoperability because that's not the same as portability. So we talk about sparse-specific platform issues like the models, categories, and ontologies, support for selection, and also support for portability. But a lot of projects mix these two. And then there are different approaches to that. Standard-based or standard proposal-based, and we do a non-standard approach, which we call, we have a suitable abstraction layer for these things, the Nucleus, instead of a standard, because I'm not so believe so much anymore in standards. Because we had our experience with the standards for BPMN and people, and almost everything worked out to be non-standardized, more or less like this. So they did not help in other areas, so our idea was they do not help here because they are not so much. I think the reasons are, the main reasons are vendors like login. It's not so much if you have a standard, it's missing features, because missing features are always bad. But you may have some special features, more comfort and so on, because that's the add-on and the plus why you get someone to buy your product and not the other standardized project. And when you use especially the special features because they're so easy to use and help you or not, you're logged in. That's normally the thing. It's like trucks. You give them for free for 1 week and then they are logged in and they have to buy it. And 90% standards do not help because the missing features are normally those that are running into problems. A lot of focus on IaaS, like the Open Cloud Computing Interface and others. And the standardized descriptions may help. Like there is this Tosca standard, and I have to admit I was not forced to show this picture, not even by Frank, which describes all these things, topologies, relations, properties, dependencies, and what they have as a life cycle and the deployment, they call it plans. And there at least is one implementation, and Cloudify area also claims they have one. Is that right? Because you find not so much information about them on the net. I've looked a little bit more clearly also in the Tosca language when I come here to Frankfurt for some time. Some of these things like the dependencies, but maybe we can discuss it later, reminded me a little bit, if you think 20 years back, Copper Component model. We have this. Yeah, from?
No, we need
Okay. Some of these things with the dependencies looked a little bit like it. Because that were not bad ideas, so why not reuse them? But it's not then the CAMP, the Oasis Cloud Application Management for Platforms. There's a new spec from May this year. I'm not sure what the implementation level is because they claim to have, they want to do a lot of things, and normally that's a good reason to believe they haven't done yet anything. Well, I'm not sure whether I'm right, because it's really hard to get, besides 1 or 2 papers, to get information on the status of these things. And normally, if I can't get information on the status, I get skeptical, because that means we are 40 years in business. Then you have Cloud for Zor, and this, all these EU-hosted projects, big projects. Their general architecture is really similar to the Nucleus design, and they have this path interoperability framework model, and it adapts at least to these 5, 6, 7 different ones. They also adapted to cloud control, so you can delete this one. Their follow-up, you find a lot of information about that. Their follow-up information about C clouds or cloud peer, and you can't find so much about them. And we heard 2 days ago about Unicorn, and I think Unicorn also tries to reuse some of this work. If I'm right? Yeah. Because that's a good idea. I think the kind of projects where you look at all the projects from the last years and think what of these things was really good and what hasn't been used so far, and then try a project to put it into use. It's not a bad idea when you think about all the money spent on this project. Then Path Manager, we out to 3 clouds at least, and you see it's almost always the same cloud platforms we want to adopt to. If you put them all together, and that was also helpful for us, we decided to use some of the same. Path Manager, then you have the co-ops, the compatible one application platform service. That's also to 3 machines, and then you have the Cloud Foundry core definition, and things like the service component architecture-based Frascati project. There are a lot of more. I don't go into the details here for them. The problem normally is it's a lot of them are either big EU projects that are stopped somewhere and we don't hear about it anymore, or there are research prototypes and you forget them after a while. I think Tosca is one of the only ones where there is a lot of force behind it, that there's a chance that you get real implementation, get it real use, and we've heard it the last days. There are a lot of different attempts to apply the same methodology to other things. So then models to describe paths, maybe the most advanced is the Passport EU marketplace. They use the CAMP, I've mentioned earlier, in an ontology-based model. It relies on Cloud for SOA. It uses the CAMP semantic model and combines that with vendor studies, and it claims to have really elaborate matching and much more elaborate matching than ours based on functional and non-functional criteria. But I think to some extent it's more a proposal at the moment, and I hope the program really will run well, then there are not so much results. Then we have Mosaic and Moda Clouds. Moda Clouds is a model-driven approach doing these things, and their comparison engine compares deployment models, for example, and this one, the Mosaic, is also an open source API for multiple clouds, and this one, it reminded me when I read these things, it reminded me especially if you look at the NIST definition of cloud computing and you try to extract every attribute to cloud computing that is in the NIST definition on these 4 or 5 pages, you find it there. And so it's really general. Okay, it's really general. I'm almost done. So I'm a little bit skeptical about that. So, what is an offer? We have a model for PaaS offerings with a catalog of more than 70 vendors, easy selection matching through the dashboard, and the Nucleus API for porting management aspects at least to 3 different important vendors. At the moment we work on partial semantic matching algorithm, and also with a startup company, I'm not allowed to name the name at the moment because we're discussing these 2 of them, to get an additional real-world scenario for all these things. So if you are interested in these things, all the software is in GitHub, and you can use the PaaS Finder online. Even this Docker container may be useful, PaaS Yard for checking machines or testing machines and things like that. And so these are some papers on it over the last years by Stefan Kroll, but also Jörg Lehnhardt. You see these are the papers that based on edit distance patterns and things like that. And that's for me, so questions.
Yeah, who has questions? I have one. Yeah. You mentioned low-level PaaS and generic PaaS. Yeah. What is the key difference between these 2 kinds?
The key difference is, for me, is I think the distinction between IaaS and PaaS is a little bit blurred at the moment. If you think of containers and Docker and all the VMs and all these things, a low level would be one where you maybe don't have a software stack, but you may have some basic management business more, and you have your operating systems, and you may have also the service for patching for security and things like that, maybe a secure environment, but everything that is going into your detailed development, like the software stack, .NET or everything, is absent and you have to install it for yourself. And normally a standard PaaS is more like you have your software stack with the connections to the databases and all these things. So I think it's not a clear, it's blurring at the moment.